In this video, we're going to talk about the individual components that are on this wiring board and how to install this in an airplane. The backbone is a plate. This one happens to be a aluminum honeycomb, and the length of it will fit on a Zenith airplane between the instrument panel and the firewall. We're using the PC310 Odyssey batteries, 2 of those. And we have major cables initially that we're going to talk about. The grounds are over on this side, and they end up in a pass-through for the firewall. We also have a ground running back to our grounding bus for the rest of the airplane. We also have the positive side, where we're running a positive cable to each contactor. To the input side of the contactor that says positive on it. We join the output sides together. We run one to a firewall pass-through, where we can go to the starter and the alternator, and we run one to power up the most essential power for the engine. As you can see, we're coming off of here, and for right now that powers up this whole panel over here, which is our engine panel. That's all powered directly then off of the contactor. The switches we're having in order to operate, start, and run the engine is a battery 1 and a battery 2. Those are grounding the contactors to get power to the system. As you can hear the clicks. We have pump 1 and pump 2 for fuel, an alternator switch on off, and an auxiliary, which could be instrumentation for the engine or the heater, so those are an option. We got 5 amp breakers for the pumps, the alternator, and the auxiliary, and a 25 amp breaker to crank the engine. So this switch only is used, or the key is only used to crank the engine, and that's all it's used for. Nothing else goes through the key switch. The back side of the switch panel is very basic. We got wires running to the bottom side of the switches on the left here, with a power bus that bridges across all the breakers. We power the power bus through the heavy cable from the main bus, so we have direct power to the engine related switches directly with no fuse in between, and then we have breakers here for the individual pumps, alternator, so forth. As you can see, the ECU for the engine is not powered through here. We'll talk about that in a second. We also power up the ignition switch, which is only to crank the engine, and it's done through this starter relay located right here. We have various power buses and ground buses. This one says not used, but it's just the screw terminals that are not used unless something is added there for the future. But it is the main power bus, power coming in from the 2 contactors and going back out here to power up all of our switches we just saw. We also have a aircraft bus, or an airframe bus here, and we have a 30 amp fuse in between our engine and our airframe. This is the main fuse where it will save the engine if something shorts out in the rest of the airplane, and that is now set at 30 amps, which is pretty adequate for most light sport aircraft. From this side, you can run wires to various buses to power up the rest of your airplane, such as maybe your lights, your avionics bus, so forth and so on, and that will then protect the engine because of this fuse. In no circumstance should any kind of aircraft related power come from this side of the fuse or any of these buses here. Next to that, we have a terminal strip. This is a terminal strip that makes it easier to pre-wire this and bring in external items such as fuel pump positive wires alternator wire and starter wire. We'll look at that in a second. And they are then, of course, they continue on, and they are what you're seeing here on the switchboard. We also added an engine instrumentation terminal strip, and the only thing that we have on this one, because everybody's going to use different instrumentation, is we do have the tack wire pull-up resistor. We have 12 volts coming off of our airframe bus to our engine instrumentation bus, and that's so that we can hook up a tack wire and power either the Viking View or some other instrument and get a signal. In addition to that, we have a grounding bus, and this is also for the engine, and it grounds things like fuel pumps, battery relays, and so forth. Now, let's talk about hooking up external things to our pre-made switch panel. The ECU, or engine control unit, is mounted underneath. From the engine control unit, there are a few wires that need to be wired to the pre-made board. The most important one is the ECU power wire or wires. They get wired into one location, so you treat this as one wire. The ECU power wire is going to go on this screw right here. So that means when power is on to either contactor, the ECU has power. And we're not using the screws because we want a nice heavy-duty secure connection to our ECU or engine control unit. Let's look at another wire. All right, we're pulling out another wire from our bundle, and we look at the label and it says starter. The starter wire will be connected to the output of our relay. So there's already a location that says start, and we're going to trim our wire and route it nicely and crimp a terminal and put it where it says start on our pre-made board. So very simple procedure. Pulling off the snake from the ECU, we grab another wire and it says alternator field. Again, very simple. Locate on your board where it says alternator. You hook up your wire and you got an alternator. As long as you throw the alternator switch on when you go flying. When you start the engine without the alternator, reduce the load, make the engine warm up for about 30 seconds or so, and then throw your alternator switch. There is the tack. Or as my friend from Texas said many years ago, the tachometer. I thought that was funny. And it is going to go over here for engine instrumentation. You just attach it on top of this terminal right there. That means that you have the tack pulse from the ECU, which is a ground, and you already got your 12 volt pull-up resistor there, so that puts 12 volts onto that grounding that the ECU does to create a pulse. And then on the other side of your terminal strip, you're going to run the output signal to your engine instrumentation, such as the Viking View, Dynon, Garmin, whatever. All right, so that's really the ECU bundle right there. You do have a 9-pin contactor. That's just for programming the ECU. If we ever come to your location and we want to program it, we can use that. And there's a couple other wires here. One says Viking View only. You're only going to use that if you use a Viking View instrument. Otherwise, and it tells you in there what to use it for. Otherwise, you just tape it off. And then there's an alternator light wire. I never use the alternator light because I can program my EFIS system to show if I have low voltage. But it is available. It probably will be phased out on future harnesses.